Hello, everybody, and welcome to Technology Today for May 11th, 2025. It's Season 2, Episode 19. I'm Mayor Watt, and we're going to talk about something weird in the universe. Alzheimer's cause in plain sight, the ITER, or ITER Magnet, creating hydrogen-6, and the greatest volcanic mystery solved. Everything's powered by ohmTown. Go over and check it out, ohmtown.com. Bippity boppity. Hey, hello everybody. I am Mayor Watt. I run that website right there. I'm never going to get it right. Anyway, go over there and check it out. It's a news aggregation service that I have been using for the last 10 years. I made it public. Now, this is 3.5 years ago. Anyway, first article is probably going to be inside Technology Today. See how it has, we have our own little channels in there. There's 50 channels that are set up under 6 main categories, 7 of which have been turned into a podcast. You can download the podcast wherever you catch pod. Anyway, the first article is over in Non Sequitur News. Scientists say that something very weird is going on with the universe. Tell me about it. This is over in the Off-World Astrophysics Cosmological Constant Dark Energy tag of Futurism in the Strung Along category by Victor Tengerman. I guess it's all strings all the way down. Astronomers have made an intriguing discovery that could upend everything we know about the structure of the universe and its expansion. We don't really know what the hell's going on. The findings could undermine the existing standard cosmological model of the universe called the lambda cold dark matter model, which takes dark energy, ordinary matter, and cold dark matter, a hypothetical form of dark matter that moves slowly compared to the speed of light, into consideration. Symbol lambda in the model refers to Albert Einstein's cosmological constant, which assumes that the universe is accelerating at a fixed rate. Yet last year, scientists concluded that dark energy isn't a constant after all. Analyzing observations by the Dark Energy Spectroscopic Instrument, or DESI, in Arizona, New Scientist reports that they've found the mysterious force could be evolving and weakening over time. They say it's exciting. Could actually be putting the standard model of cosmology in danger, says Autonomous University of Madrid assistant researcher Professor Yashar Akrami, who said that to New Scientist. So, if you prove that quintessence is dark energy, it's very good for string theorists. That's why the string theory community is really excited right now. We've all grown up thinking about the universe as having a gravitational force, and gravity fuels everything. But now there's going to be an additional fifth force, which is due to the dark energy, which also fuels everything. So the universe is a hybrid. All right. Researchers believe it's most likely that scientists will debate different models of dark energy and never resolve it. Yay. Let's keep going. Next article is over in Technology Today. Scientists discover hidden cause of Alzheimer's hiding in plain sight. Researchers found that PHGDH gene directly causes Alzheimer's and discovered a drug-like molecule, NCT503, that may help treat the disease early by targeting the gene's hidden function. A recent study has revealed that a gene previously identified as a biomarker for Alzheimer's disease is not just a marker, it's a direct cause. I was about to make a joke. Like, what? What am I doing? University of California, San Diego put this article together. It's published over at scitechdaily.com. Thank you very much. Discovering those causes could ultimately improve medical care. Unfortunately, treatment options for Alzheimer's diseases are very limited. Alzheimer's disease. And treatment responses are not outstanding at this moment. And we don't understand it. So Zhang and his team took a closer look at phosphoglycerate dehydrogenase, or PHGDH, which they had previously discovered as a potential blood biomarker for early detection of Alzheimer's disease. In a follow-up, they later found that expression levels of PHGDH gene directly correlated with changes in the brain in Alzheimer's disease. In other words, the higher the levels of the protein and RNA produced by PHGDH, the more advanced the disease. That correlation has been since verified in multiple cohorts from different medical centers, according to Zhang. So PHGDH creates an enzyme key for the production of serine, an essential amino acid and a neurotransmitter. Because PHGDH enzymatic activity is also only known that role, the researchers hypothesized that its metabolic function must be connected to an Alzheimer's outcome. However, all their experiments designed also failed. At the time, our study hit a wall, and we didn't have an actual clue of what mechanism it is. The researchers were curious if PHGDH had an unknown regulatory role, and they turned out to use modern AI for help. They really demanded modern AI to formulate the three-dimensional structure very precisely to make this discovery. So now that the researchers have uncovered the mechanism, they wanted to figure out how to intervene and thus possibly identify a therapeutic candidate which could help target the disease. Given that PHGDH is such an important enzyme, there are past studies on possible inhibitors. One small molecule known as NCT503 stood out to the researchers because it's not quite effective at impeding PHGDH's enzymatic activity, the production of serine, which they did not want to change. NCT503 is also able to penetrate the blood-brain barrier, which is a desirable characteristic. So they turned to AI again and again and again. So now there is so the researchers do acknowledge limitations in their study, one being that there's no perfect animal model for spontaneous Alzheimer's disease. They could test NCT503 only in the mouse models that are available, which are those with mutations in those known disease-causing genes. Still, the results are promising. So maybe we'll be able to use this to limit the, I guess, either the permanence or the onset of Alzheimer's. Let's keep going, though. The next article is over in Technology Today as well. ITER, or ITER, just completed the magnet that could cage the sun. In a breakthrough for sustainable energy, the International ITER project has completed the components for the world's largest superconducting magnet system designed to confine a superheated plasma and generate 10 times more energy than it consumes. This electromagnetic heart of the tokamak, created through cooperation among 30 nations, is a triumph. The article is by ITER, and it's published at scitechdaily.com. Pardon me. So the final piece of the puzzle, a towering central solenoid magnet built and tested in the United States, is strong enough to lift an aircraft carrier, it says. Once installed in the ITER facility in southern France, it'll serve as the powerhouse of the fusion reactor, working alongside 6 giant ring-shaped magnets from Russia, Europe, and China. The thing about this is, if you pay attention to this thing, it's this unique shape. But what's interesting about this is what has been happening is the plasma actually finds a weakness in the magnetic field and touches the sides. And when it touches the sides of the magnetic field, following the lines of flux, it's like water, and it finds the weakest portion of it and kind of pushes out and touches the wall, and that does damage to it, and it could be catastrophic. Lately, though, they've only been detecting little touch points, and then the sensors go wonky. So altogether, the magnet system will weigh nearly 3,000 tons. It forms the electromagnetic heart of ITER's tokamak, a futuristic donut-shaped reactor that aims to replicate the energy of the sun here on Earth. They talk about how does the pulsed superconducting electromagnetic system work, and they actually discuss this, but I'll let you go over and check it all out. The thing about this thing is that it's supposed to give off more energy than gets put into it to either stabilize it at a certain level or to fire it off. We'll see. The past 5 years have been witness to a surge in private sector investment in fusion energy R&D. In November 2023, the ITER Council recognized the value and opportunity represented by this trend. And so they've accepted outside investment, I believe. The U.S. has also delivered to ITER, the exoskeleton support structure that will enable the central solenoid to withstand the extreme forces it will generate. The exoskeleton is comprised of more than 9,000 individual parts manufactured by 8 U.S. suppliers. Additionally, the U.S. has fabricated about 8% of the niobium tin superconductors used in the ITER toroidal field magnets. Then Russia and Europe, China, Japan, Korea, India have also taken part. The next article is over in Technology Today as well. Scientists create ultra-rare hydrogen-6 isotope defying nuclear physics. I'm going to jump straight on over this. I'm losing my voice all right. Whoa. That is not what I wanted to do. Anyway, have nothing to do with Telegram. The Johann Gutenberg University Mainz put the article together. It's over at SciTech Daily. And researchers from A1 collaboration at the Institute of Nuclear Physics, Johann Gutenberg University Mainz, in partnership with scientists from China and Japan, have successfully produced hydrogen-6, one of the most neutron-rich isotopes, using electron scattering for the first time. Conducted at the spectrometer facility in Mainz Microtron, or MAMI, particle accelerator, the experiment introduces a novel approach to studying light, neutron-rich nuclei. Light as in weight, not light as in light bulb. Light bulb. Losing my mind. Anyway, the experimental work was led by doctoral student Tianho Shou and has been published in Physical Review Letters. They describe limits of nuclear structure in extremely neutron-rich systems. One of the most fundamental questions in nuclear physics is how many neutrons can be bound in an atomic nucleus with a given number of protons. And for the fundamental isotope hydrogen, which contains only a single proton, several very neutron-rich isotopes from 4H, 7H have been observed beyond well-known deuteron and triton. So the extremely heavy hydrogen isotope 6H, consisting of 1 proton and 5 neutrons, NH7 or 7H, with 1 more neutron, have the highest neutron to proton ratio so far. Together with the Chinese and Japanese scientists, A1 collaboration developed a new approach for introducing or producing 6H. In the method, an electron beam with an energy of 855 mega electron volts impinges on a lithium IS7 lithium target, producing 6H via a two-step process. First, a proton in the lithium nucleus is resonantly excited by the interaction with the electron and promptly decays into a neutron and positively charged pion. If this neutron subsequently transfers its energy to another proton within the nucleus, it can form the neutron-rich hydrogen isotope 6H, together with the residual nucleus, while the pion and the proton leave the nucleus and can be detected and simultaneously together with the scattered electron using 3 magnetic spectrometers. So basically they want to pull it apart so that the electron goes in one direction. So a proton in the lithium nucleus is resonantly excited by the interaction with the electron and promptly decays into a neutron and positively charged pion. So there you go. They did a 4-week measurement campaign. Approximately 1 event per day was observed as it had been estimated. It was one of the rare experiments at MAMI in which all 3 high-resolution spectrometers at the A1 experimental hall were operated simultaneously in coincidence mode so that they could see the 3 particles get detected at the same time. But that's it, folks. That is it for Technology Today, and I will see you on the other side. Bye-bye.